All right. So we wanted to talk about bond polarity. I assume you're talking about these, right? So when we're talking about these, we draw the Lewis dot structure. Can you see where there's a concentration of electrons over on this side of the molecule? Then this side, because electrons are negative, this side of that molecule is going to be negative. Okay. This side will be positive. We can draw our arrow and then we put the plus symbol at the end where it's positively charged. And then the head of the arrow points towards the negative end. When you're talking about in terms of this, anytime you have these lone pairs of electrons on that central atom, that is going to make one of these automatically polar. Okay. And you're going to take your arrow and you're going to point it towards those lone pairs of electrons. So that's what I tried to do here in terms of trying to show you these, that's where the negative charge is going to end up being. Because remember, this is actually bent. So if we were to draw this kind of correctly in terms of a VSEPR structure, we would draw it. Okay, no, that's not what I want. I want this guy right here. It would actually be drawn like this to where this is coming out down here because this is a bent structure. And we'd have a double bond here. And that's why that arrow would be drawn like that. Okay. So I did not do this kind of justice. I drew it in a linear fashion, even though it's technically bent. And now I've got it drawn properly. All right. In terms of electronegativity, when we're talking about the different bonds, and I will give you a chart of electronegativity. I've got it on my list of things to run off. In terms of electronegativity, if you're looking at the electronegativity of a specific bond, then we're looking in terms of different. We've got nonpolar covalent is going to be between 0 to just a little bit shy of 0.4. 0.4 to 1.67 is going to give you polar covalent. Do you think this thing will let me move it out of the way? There we go. And then 1.67 and higher is going to give you an ionic bond. But remember, you can have polar bonds where you have a nonpolar molecule, because if all of those electrons balance out, then you've got a polar molecule, or I'm sorry, a nonpolar molecule. And I kind of gave you an example of carbon tetrachloride here. If you had carbon tetrachloride and you looked at the electronegativity of these chlorine versus the carbon, you're going to come in squarely at a polar covalent bond. But because all of this is balanced out and symmetrical, then you end up having a nonpolar molecule, even though you have polar bonds. Okay, the whole thing will be balanced out, so it's going to end up being a nonpolar molecule. Kind of overrides it. Okay, what else do you want to talk about? Do you need a name refresher? Potentially. So remember, I had given you a kind of a flow chart to help you out with naming. I'm going to give you a copy of this to use on your test tomorrow. Okay. So if you've forgotten that, if you've forgotten any of the numeric, covalent prefixes and stuff, that's all on there as well. Okay. So when you are given a problem, the first thing you should look at, if you're trying to figure out the name here, you're going to look to see if it starts with an H. Okay. If it starts with an H, it's going to be an acid. And then you've got to figure out what type of acid it is. Well, this has oxygen in it. So it's not going to start with hydro. You are simply going to figure out what that polyatomic ion is and then change its name to the acid form. So we have PO2 here. If we look on our polyatomic ion sheet, we can find PO4 with a -3 charge. Okay. And next to that, it's going to say phosphate. So if this is PO2, we have to change a couple things. We have to change the 8 to an ite. So we're going to get our polyatomic established first. Okay. So this is going to be ite, and it's going to start with hypophosphite. But then when we change it into the acid form, if you take a bite of something, it tastes gross. We're going to change the ending then to OUS. Okay. And this becomes hypophosphorus. If you forgot that OR right there, I'm not going to mark you down. I'm looking for this, and I'm looking for this. All right.
What is that?
That is the answer to this question here. That is what H3PO2 is. So you look to see, does it have hydrogen at the beginning? If it does, then it's going to be an acid. Then you've got to figure out if it has oxygen in it. If it has oxygen, then you're going to start by identifying what that polyatomic ion is. This polyatomic ion is hypophosphite, and then you change the ite to ose to be able to get the answer. Okay. Now, what if it doesn't have oxygen in it? Okay, so if this is our formula, if it doesn't have oxygen in it, then you're simply, and it starts with hydrogen, then you're dealing with an acid. You're going to start with the prefix hydro. Then you're going to find what element this is. And then you're going to add the ending ic and then acid. So no oxygen. It's going to start with hydro and it ends in ic.
That's only with like when it doesn't have oxygen.
Right. Yep. So you can have a situation like this guy. Okay. There's no oxygen here. CN is a polyatomic ion. So if there's no oxygen, what does it begin with? Hydro. This is called what? What is CN minus? Huh? Cyanide. So this is going to be hydrocyanic, because we remember we change our ending to ic. We start with hydro, we end with ic, and then it becomes acid. Okay? Easy enough? Remember those? Hmm?
Do we have to turn the review in?
No, I just checked to see if you had done it. All right. So what if it doesn't start with H? Then we need to look. Are all of the elements in there nonmetals? If they're all nonmetals, then we're going to go with the covalent naming procedure. All right. Then you look, okay, this is oxygen. Remember, the first word always gets spelled out fully. if there's more than one of them, we have to use a prefix, and I'm giving you these prefixes for the test tomorrow. The next one then always gets a prefix no matter what, and then it ends in "ide." Now here, with this one was 2 nonmetals. We're beginning with phosphorus. There's only one of them since there isn't a prefix in the beginning. The second one always gets a prefix, and that's that guy. Good? Everybody remember all those? Making sense? All right. Then our third and final type of naming was dealing with a metal and a nonmetal. Okay. So here we had magnesium carbonate. Remember, if it ends in "ite" or "ate," it's going to be one of these polyatomic ions, and it's going to have oxygen in it. "Ite" or "ate" always has oxygen. So magnesium, we're going to write that out. We look up its charge. It is a +2. Carbonate doesn't appear on our polyatomic ion sheet. What does? It's related. Carbonate. Carbonate is CO3. This is carbonite. So ite has one less oxygen. It is a -2, so we don't need to do anything with balancing. Our charges are already balanced. Okay. Here, if we look at this guy, aluminum is a +3. Hypobromite, we don't have hypobromite on there. We have bromate. Bromate is BrO3 with a -1 charge. So this is a -1. Hypobromite is going to be 2 less oxygen. So it's BrO. And we need to balance out our charges. So I need 3 of these for every 1 of these. It has to be in parentheses and the 3 outside. Good? Remember how to do all those? Questions? Issues? Merit?
Number 23, wouldn't it be a covalent? So you would do it like dihydrogen hyposulfite.
No, this is acid.
Oh,
okay. It just didn't get subscripted. But it starts with an H here. That's going to be an acid. So it's going to run by acid naming rules.
okay.
Just forgot the subscripts. It's a pain to type. That's why I run off stuff for you guys instead of making you do it all in Chromebook stuff, because it's painful to try to get all of that stuff done. And sometimes it gets left behind, like this one. So you just kind of have to go with the flow. The other problem is that like in Classroom, if I try to do something in Classroom, I can't subscript in there. There's no option for it. I also can't subscript in Google Sheets. There's no options in those to be able to subscript in any of that stuff. And so it's frustrating because when you're trying to type stuff, you can't format it properly. I don't know if other areas have the same issues like Spanish and French and stuff where they've got their extra little tildes and accents and stuff like that. I don't know if they run into the same problem that we do, but it's just darn near impossible to try to do any kind of mathy chemistry kind of stuff on the computer. It's just painful. So I run up my copy money and I'm up to $359. So that's been going for a couple of years now. So I don't feel bad. Yeah. But I am probably one of the leading copy people in the building just because it's awful. All right. What else do you want to talk about in terms of naming, writing formulas, that sort of thing? You're going to need to make sure that you are absolutely solid on this because we are getting ready to take these and make them into compounds or reactions. Okay. So you'll get a problem, something like aluminum phosphite plus calcium chloride. And you have to know how to write these out and then be able to swap things around to create new products. And if you don't know how to write those formulas, you're in for a painful existence coming up. So make sure that you've got this solid down and you don't have any questions on it. All right. What other stuff do you got for me for class? Anything?